Number 4, we want to determine if the following function has an inverse. And so one of the, I guess, the short ways of thinking about this is if you can recall what the parent function looks like. So let me go back and show you some of those graphs. I think, yeah, module 2 and parent functions. So I guess I need to go full screen so we can see it all. We're looking at a radical function like this, and what you want to consider is if this function is 1-to-1. So 1-to-1 is covered in this section. I haven't talked about it. 1-to-1 1-to-1 simply means if a function will pass the horizontal and vertical line test. So just for example, let's say if I had a parabola. If I drew vertical lines, each vertical line would only cross one time. Once, once, once. So it would pass. That's what it means to be a function. Now if it does the horizontal line test, it does not pass. Okay. So this parabola is a function, but it's not 1-to-1. Okay. Usually those 1-to-1 functions are basically of odd degree of power. So if I just did a linear equation, this would pass the vertical line test, meaning that it is a function, crosses only once. And it would pass the horizontal line. So no matter where I drew a horizontal line at, each horizontal line would only cross one time. So that's what it means, 1-to-1. 1-to-1, each x value, we'll just say, is paired with exactly one y value. And vice versa, each y is paired with exactly one x. And in this one, x is paired with one y, but we have this y, whatever this y value, paired with two different x values, if you were to trace that down. So the square root function right here, go back full screen, this one would pass both vertical and horizontal. So we would say this would have an inverse. You don't even have to find it. You just need to know what that means. Does this one have an inverse? So look, the biggest power is x squared. All right, x squared is the parabola that we just talked about. So this function is not 1-to-1. So therefore, we say it does not have an inverse.